acceleration, displacement, and velocity, right? So there are two things we sometimes you see x standing for displacement, or sometimes in some books you see s, right? Some books use s, some books use x for displacement. We have u for initial velocity. Velocity is speed in a direction, right? We have v. Can anyone tell me what v stands for? V is final velocity. So you can't say, sir, I don't know about these things, right? Why I'm going to say that? Because distance time is a concept, so it's a CSEC concept. So even if we aren't teaching it, we should have done it. If we didn't do it, then call your maths teacher and ask them why they didn't teach you distance time in school.
Physics or ethics?
Oh, so you did it in physics? Yeah, but remember, it's a concept in CSEC math also. You have the displacement time graph, and you have the velocity time graph. A is for acceleration, and we have T is for time. So I'm going to see how quickly I can go through. And this is basically straightforward as well. So if you are given a formula that gives you the distance, let's say x is equal to a function of t, right? So I need you to copy this, please. And this is the displacement. So a function of t simply means when you get the value of t, you just put it in and you'll know the displacement or the distance moved. If you want to find the velocity is the derivative of your displacement function. Right? So if you have your displacement function, they ask you for velocity, you have to differentiate. So if I differentiate x with respect to t, I'll get dx over dt. This simply means if you're giving your displacement function and it asks you for velocity, just differentiate this function that they give you. Is that clear, everyone?
Yes, sir.
And if they ask you for acceleration, how are we? Acceleration is how we are changing our velocity over time. When you mash the x, if you keep your foot on that x for a period of time, do you stay at the speed or you increase your speed?
Increase.
Very good. So that's acceleration. You're changing your speed now. So acceleration is a change in speed. So acceleration is the derivative of velocity. So A, it means I now have to differentiate this function. That will be now my dv, the change in velocity as time changes. So please copy this here. This is very important. Because most times you will get a question based on acceleration and velocity and displacement. I just want you to see that this is our first derivative and this is our second derivative, right? So if we integrate acceleration now, let's talk with respect to t. What should I get if I integrate acceleration? I start at acceleration and I integrate it. So I'm moving backwards now. What should that give me?
Velocity.
Wonderful. So the integral of acceleration is velocity. And if I integrate my velocity function, what should I get?
Displacement.
Displacement. So this is also important for you. Good. So now we can look at the question that I sent in the group. Oh, 4t squared minus t cubed. And x is displacement, right? Or the distance that we travel. 4t squared minus t cubed. We are asked to find velocity. We are asked to find everything. Displacement, velocity, and acceleration when time is equal to 0 and when time is equal to 2. And this is seconds, right? We are looking at our time in seconds. So if we want to find our displacement when time is 0, what do we have to do? We want displacement when time is 0. What do we have to do? This is our displacement function. Come on, talk to me. No one? Do we already have a formula for x here?
Yes, sir. You input when
Yeah.
t is equal to 0.
Wonderful. That's basically what all we have to do is substitute. So the displacement when time is 0, our displacement is equal to 4 times our time, which is 0 squared, minus our time cubed. So what this is saying, when time is 0, at 0 seconds, our displacement is 0. This means that the particle is not moving. At time equals 0, there's no displacement. You're right where you were or you're stationary. No displacement would occur at that time. Right? What about the displacement when time is equal to 2? X when time is 2. What do we do here?
Same, you substitute.
Very good. So it will be 4 2 squared minus 2 cubed. So 2 squared would give you 4, 4, 4, 16, minus 2 cubed is 8. So our displacement is what?
8.
8.
Execute.
Good. And it will be 8 meters, right? Because, as I said, the displacement is a distance. So at 2 seconds, whatever this equation is modeling, let's say it's a car moving on a circuit or something, at time equal 2 seconds, the displacement would be 8 meters.
Wouldn't the meters be meters per second, m/s, or just the m alone?
It's a distance we want. The displacement is a distance, right? So if I ask you, Miss, what's the distance that you walk? You would tell me in meters, isn't that so?
Yeah.
Great, right? So the displacement would be in meters, km, and that's all, right? But in this case, we are taking it in meters. Cool with everyone? When t is 0 and when t is 2. So how do we get the velocity? What do we need to do now?
We differentiate the displacement.
Wonderful. And v when t is. So to get the velocity, we have to differentiate the displacement function. So when we differentiate here, we'll get dx dt, which is simply v. So v is equal to, when we differentiate, we get 2 4s 8. Will that be 80? Yes, no? Where are we differentiating here? Is that correct?
Yes, sir.
Minus 3t squared. When we substitute, so this is our velocity function, v is equal to v0 minus 3 0 squared. Our answer is still 0. So if we have no displacement at time equals 0, we can't have any speed because we're not moving. Right? So it's congruent, makes sense. If the displacement is 0 at time equals 0, then the displacement, as you can see here, is also, in this case, it's also 0, no speed. Are we good so far?
Yes, sir.
So what is the displacement when time is equal to 2? After 2 seconds, not displacement, sorry, what is our velocity after 2 seconds? How fast are we moving? So we use our velocity function. We have
And meters per second.
8 2's minus 3 t square is 2 square.
Yes, sir.
16. All right, so remember we have to square here, right? So 2 square would give us
4.
4, and 3 4s would give us
12.
12, right? So what's our answer?
4 meters per second.
Wonderful. So you're moving now at 4 meters per second. Is that clear? Our function for acceleration, what do we do?
Differentiate v or the second derivative of.
Very good, very good. So if the v dt, so when we differentiate our velocity function, we get acceleration. So when we differentiate 8t minus 3t, what will we get? So when we have 3t squared, when we differentiate that, what will we get? All right, so the next thing would be we are asked to find the acceleration when t, so the acceleration is 8 minus 60, when t is equal to 0, and we're also asked to find the acceleration when t is equal to 2. So basically, what do we have to do here?
Substitute 0 and 2 into the equation.
So go ahead and let's see what our answers are. Meters per second squared, right? So it's meter per second squared. That's what we use for acceleration. When you do the next or the final math course, that's called mechanics, you will see why we use meter per second square and all of that. I could show you it now, but that's not the most important thing at the moment. So the acceleration at time equals 0 is 8 meters per second square. And what's the acceleration at t equal to?
We got negative 4.
T. So it will be 8 minus 6 twos,
Yeah.
12. So it's negative 4 meters per second square. Now, what is negative acceleration means, right? Can anyone explain what a negative acceleration tells or is saying?
Decrease in speed.
Very good, very good. Right? Differentiation. So as you can see, if we want to come down, we differentiate. Right? So if we start with displacement, then we want velocity and acceleration, we differentiate. But if we want to go up, what do? We integrate, right? So that's basically it. Any questions pertaining to these two topics that we have touched?